Hey guys, this side Anirudh. I'll be your trainer today. So we have few sessions that we already gone through for BGP. So welcome to the next session. Let's go on.
I was having a very small topology of BGP. However, by looking at this topology, it is looking very huge topology here. But here, at the end of customer, we are running BGP only on R1, R5, and R6. R5 and R6 are working as customer edge routers, as you can call them as customer edge 1, another customer edge router which is R6, and all other devices, all other routers are customer routers. So at the end of customer, we are having 6 routers over here, as you can see: R1, R2, R3, R4, R5, and R6. Out from these 6 routers, R5 and R6 are working as edge routers, and of course R1 is having BGP peering with R5 as well as with R6. Fine. So let's move on R1 now, and you can see here, show IP BGP summary, that it is having neighborship with both of them, I mean R5 as well as R6, as you can see here, right? So basically the diagram is something like this, because some people were absent in previous class, that's why I'm repeating this diagram now. This is R1. R1 is having neighborship with R5 as well as with R6, and then further R5 and R6 are having neighborship with, like here it is Sprint, and of course there is another router which is what, BT, and of course R6 is connected with BT as well, and then further BT is connected with Neo router, right? This is, and it's using AS 65500. You understand? So here you are using this diagram, I mean I'm using this diagram, but as you can see, this is my logical diagram, but my physical diagram is this. So basically there is a black hole, because I'm not running BGP onto R3 as well as R4. So there is a black hole, so you cannot, of course you cannot perform ping. I cannot perform ping, but the main thing, the most important thing here that we have to perform is just to manipulate BGP path selection. So I will be manipulating BGP path selection with using some BGP attributes such as wait, local preference. However, I have already configured wait as well as local preference, but some of the part of local preference is still left. So I will cover that part of local preference first, and then I'll go for next attributes like AS path attribute, and then I'll go for origin code, then I'll go for MAD and all these things, right? So now I'm going to start it, right? So this is your topology now, this is right. So now you can see, and I have to configure this R1 as route reflector as well. You know why? Because in case if R6 lost its connection with BT, then R6 will not be able to receive prefixes coming from R1, because for R1 both of them, R5 and R6, are IBGP neighbors. So in case if R1 is receiving anything from R5, then definitely it will not advertise it towards R6, and if it is receiving anything from R6, then it will never advertise it in the direction of R5. So it will be required for us to configure this R1 as a route reflector. So let's move there on R1 and configure it as a route reflector. Router BGP 65500, configure neighbor 150.1.5.1 route reflector client, and in same manner you have to configure your R6 as a route reflector client itself, right? So see, show IP BGP summary. Now it's in ideal state, I mean it's in active state now, you see, and now you will see that neighborship will come up very soon. So once neighborship will come up, you will see that this R1 once again will start to receive prefixes coming from R5 as well as R6, right? Because R1 have to receive prefixes from both neighbors. Let me show you. It has formed neighborship with R5. It has to form neighborship with R6 as well. So it has formed neighborship with both of them, and now you can see prefixes are coming from both of them, R5 as well as R6. Because, and see, next hop addresses are changed over there, because I have already configured next hop self command onto both customer edge routers like R5 as well as on R6. I already configured this next hop self command for this IBGP neighbor, right? Because R5 and R6 are receiving these prefixes from their eBGP neighbor. So if you are receiving prefixes coming from eBGP neighbor, and if you are advertising them towards IBGP neighbor, then definitely next hop will not change automatically, but after configuring next hop self command, of course it will advertise those prefixes routes towards IBGP neighbor, but after modifying their next hop address. Have you understood it or not? Hello, have you guys understood it or not? So in previous class I have discussed all these things. I already discussed all these things, right? So now I'm going to manipulate this path selection with using local preference. So I'm not gonna to discuss anything else related to previous class, right? Because it will take so long time. Because we have spent like approximately 1.5 hours just to understand weight and local preference, right? And of course the behavior of BGP as well. Like as I taught you that in BGP it will advertise only and only past path information towards its neighbors. That is, this feature is taken from distance vector routing protocols into path vector routing protocol. In this BGP, right? So I have already discussed all these basic rules of BGP with all of you. So I'm not going to discuss it once again over here. So let's go for local preference now. You see that right now its best path is via R5, and the election is based on, I think, IGP cost to reach next hop, as you can see here. So IP BGP 191.168.100.0. Of course, via R5 it is having metric only 12 as compared to via R6, because via R6 its metric is what, 75. So definitely lower IGP cost to reach next hop will always be preferred. So based on lower IGP cost to reach next hop, it has defined its best path via R5. So we can do one thing to solve this problem. If we do not want to let routers to elect their best path selection based on ICP cost to reach next hop, what can I do? I can move on R4's F2 by 0, as you remember that we did it in previous class as well, right? And we can configure its cost same as serial interface. So here on its serial interface it's 64. So here on R4's F2 by 0, I'm again gonna to configure its cost as 64, right? So let's move on R4 and go to its F2 by 0. IPOSPF cost is what, 64. Right, and then I can go for R1, show IPBGP, see show IPBGP 100.0, 75, and this is once again 75, right? So you can see here that cost is now ICP cost to reach this next hop is common via both neighbors. So of course now election will be done based on their router IDs, right? And you know very well, you understand very well that how BGP is selecting its best path, right? So I'm not going to describe it once again. So let's go for local preference finally, right? So via both neighbors, via R5 as well as via R6, for all prefixes its local preference is what, 100, which is default local preference. And in previous class I have taught you that how can you modify the default local preference of routers. So let's say that I want you to configure its best path via R5, because right now traffic for all these prefixes will go via R5 only, right? The traffic will never follow R6. Outgoing traffic, the traffic which is leaving RAS, the traffic which is leaving our own network. So I'm talking in perspective of outgoing traffic only. I'm not talking in perspective of incoming traffic, because see, whenever this New York router will transmit any traffic towards customer, so of course that traffic for customer, for this NBT network technologies, it will be known as incoming traffic, right? But this time I'm talking about that traffic which is going towards New York router, means the traffic which is leaving our network, because these prefixes from New York router are incoming prefixes for customer, right? Hey, for customer these prefixes are incoming prefixes, whereas traffic will always be, data will always be outgoing traffic, right? Data will always be outgoing data. So basically you are trying to modify path selection for that outgoing traffic, for that outgoing data, right? So here you do one thing, move back again on R1 and you see show IP BGP. This is your PCP table, right? And next hop addresses are configured as like 150.1.6.1, 150.1.5.1, 150.1.6.1.1.5.21, right? So is there, everything is fine now. So to reach all these prefixes we have to pass via R6 or via R5. Best path is by default via R5 based on router IDs. So whole traffic which is going towards these prefixes will go via R5 only. It will never go via R6. Now I want to perform some kind of load balancing and all, or I just want to manipulate its best path selection. I want that its best path should be via R6 only. Its best path should be via R6. So what can I do actually over here? Because as I said that whenever prefixes will come from eBGP neighbor, it will come without any local preference. But by default local preference for BGP is what, 100. So whenever it will advertise any prefix towards its IBGP neighbor, it will advertise with the local preference 100. So whenever R6 will receive these prefixes coming from BT, it will receive it without any local preference. But whenever R6 will advertise these prefixes in the direction of R1, it will advertise it with local preference 100. So what can we do? We can move on R6 and we can modify its default local preference, right? So what can I do? Router BGP 65500 BGP default Yes, default BGP oh my god, yes, BGP default local preference, which is, let's say this time it is what, 101. So just after configuring its local preference as 101, you see what will happen. It will start to advertise these prefixes towards its IBGP neighbor with the local preference 101. So whenever these prefixes will reach now R1, so you will see this BGP table. See, for all these prefixes, its best path have become via R6 only for R1. And this time you see that R1 have also stopped to receive these prefixes coming from R5. Previously, this R1 was receiving these prefixes from both of them, R5 as well as R6. But this time it is receiving these prefixes coming from R6 only. And its best path is via R6. You know why? Because whenever it will advertise this information, because right now this R1 is working as route reflector as well. So it has to advertise this information in the direction of R5 as well. So whenever it will advertise this information, these prefixes in the direction of R5, see what will happen, that R5 will receive these prefixes with the local preference 101 coming from R1. Actually here in BGP table it will look like they are coming, I mean these prefixes are coming from R6. No, it is not receiving these prefixes from R6, because you know very well that if you are receiving anything from IBGP neighbor and you are giving it to another IBGP neighbor, its next hop address will never get changed. So basically here next hop address was not changed. So because next hop address was not changed, that is why it is looking like that these prefixes are coming from R6. However, these prefixes are coming from R1 only, as we can see here. So IP BGP 192.168.100.0. However, this R5 is also receiving same prefixes coming from its eBGP neighbor as well, which are, this is Sprint 205.100.100.10, and this is what, BT 200.105.100.1. This is BT's address, right? So this prefix is coming from these different three neighbors, from these three different neighbors, from these three different neighbors, right? I mean, it is receiving, R5 is receiving this prefix, this particular prefix from R1, from BT, from Sprint, but its best path is via R1. See, internal. You know why? Due to, and I have also discussed it in previous classes as well. Fine. Move back again on R1. So IP BGP. That's fine. Its best path is via R6. But the problem is that it has changed local preference for all prefixes this time. I just wanted to perform, I just wanted to define its best path for last two prefixes only via R6. That's so that I can get some load balancing. Now you will not be able to get load balancing. So you do one thing, move back again on R5. Sorry, on R6, because on R6 I configured its default local preference, right? 65500, and remove this command now from here. Once you remove this command, right, so it will start to advertise all these prefixes with its default local preference, which is by default 100, right? So let's move back again on R1, and you will see that all prefixes will come from both of them with the local preference, with the default local preference. And this time you see that once again for R1 its best path have been defined via R5. Fine. So I just wanted to manipulate its best path selection only for last two prefixes. So what can I do? I can do it on R6 as well. I can do it on R6 as well, and also I can do it on R1 as well, but I can't perform. Yeah, I can also do it on R5 as well. I can also do it on R5 as well. Now I will let you know that how and where we can configure this BGP. We can modify this local preference in BGP, right? See, I'm just manipulating that traffic path selection which is leaving our network. Outbound traffic. You are talking about only and only outbound traffic. Fine. So you do one thing. See, this time R6 is advertising these prefixes towards R1 with local preference 100. What can I do? I can move on R6 and see R6 is receiving these prefixes coming from BT, right? Without local preference. Of course, whenever updates will go towards a BGP neighbor, it will never include local preference. Fine. Even I think I have already proved it, that local preference was not part of path attributes when it was giving an update to its eBGP neighbor. But whenever BGP was giving its updates to iBGP neighbor, then local preference was always there. Fine. On R6, what will I do? See, this time it is receiving these prefixes like 100, 101, 102 from its eBGP neighbor, and from its eBGP neighbor, its local preference is nothing, because whenever it will receive these prefixes from its eBGP neighbor, it will not find any local preference. That is why here nothing. But if your local preference is not anything, by default it is considered as a 100. By default it is considered as 100. So what will I do now? I will modify it only for last two prefixes. What will I do? I'll say that IP prefix list CCIE permit 192.168.102.0/22 greater than equal to 24 and less than equal to 24, so that 102 as well as 103, those two prefixes will match with this statement, right? Then after, I'll create one route map here with the name of LP local preference, and I'll say permit 10 match IP address prefix list name was CCIE, and then set local preference 101. Then do one thing, because all those prefixes which are permitted inside this prefix list, which are matching with this prefix list, will be permitted by route map, and all others will be implicitly denied. To allow all other prefixes, create another statement of the same route map with higher sequence number, let's say 11. Don't match anything, don't set anything. By default, match all is there, and of course you are not required to set anything. You have to receive all other prefixes with the default BGP path attributes, right? So you do one thing now. You do one thing. See, this time you can apply this route map into two directions. If you want to apply it for neighbor R1, then you have to apply this route map in outbound direction, because for R1 you are giving updates. Hello. Yeah. For R1 you are giving updates. But if you want to apply it for eBGP neighbor, then you have to apply it for incoming updates. You have to apply it for incoming updates, because it is receiving these prefixes from BT but giving these prefixes to R1. So you can apply this route map for R1 as well. You can also apply this route map for your eBGP neighbor as well. But if you are applying this route map for eBGP neighbor, remember that it will be for incoming updates. You have to apply it for incoming updates. And if you are applying it, if you are configuring this route map for your iBGP neighbor R1, then you have to apply it in outbound direction. Have you got it or not? So you do one thing now. Say go to router BGP mode, router BGP 65500. Say neighbor 150.1.1. Or do one thing. Let's apply it for eBGP neighbor first. Neighbor 201.100.100.1, and then route map. Route map name was LP. In which direction? In. So this was your route map, right? Now you see do show IP BGP. Here you will see that there will not be any effect of your changes, right? Do one thing, do clear IP BGP star in, and now say do show IP BGP. Check it out for last two prefixes only. See, when it received these prefixes from its eBGP neighbor, at that moment it was not having anything, any local preference value. But now what I did, I configured a route map that okay, if you are receiving an update from eBGP neighbor, then before installing these prefixes in your BGP table, make sure that you are having their local preference as 101. Remember, for eBGP neighbor, remember here I'm gonna tell you one rule of for local preference for eBGP neighbors only. If you are configuring local preference for eBGP neighbor, you can configure local preference for eBGP neighbor only for incoming updates, only in incoming direction, only in inbound direction, not in outbound direction. Remember, you cannot configure local preference for eBGP neighbor in outbound direction. You can configure it in inbound direction only. You know why?
Yes,
exactly, because you cannot, BGP will never carry local preference attribute within its BGP updates for eBGP neighbor. Hello. Local preference cannot be configured in outbound direction for eBGP neighbor, but you can configure it in inbound direction, because now you have received update and then you can modify it according to yourself. So remember, for eBGP neighbor, you can modify local preference in incoming direction only, not in outbound direction. Because it is not part of BGP updates. If BGP updates are going towards eBGP neighbor, right? Fine. So now we have configured it for eBGP neighbor for its incoming updates, right? So that it have configured its local preferences 101. So it will advertise these prefixes in the direction of R1 with local preference So its best path for R1, its best path for last two prefixes have been configured via R6. And now R1 will also advertise these prefixes information towards R5 as well with the local preference 101. So for R5 itself, its best path will become via R6. Take it out. Is not it? Hello. Even for R5 also, its best path have become via R6 to reach last two prefixes. Hello. Because this time R5 have started to receive modified local preference. Fine. So I applied this time this route map on R6 for its EBCP neighbor for its inbound. Exactly. In its inbound direction. Now move on R6 once again and do one thing. Remove it. Router BGP 65500. I'm gonna remove it. Show IP BGP. Fine. Now what will I do? This time I will apply on R6 this route map, but in outbound direction for its neighbor R1. Move on R6. The neighbor 150.1.1.1. Route map name is LP in which direction? Do clear IP BGP start out. See in its BGP table is default nothing, because this time we configured this route map in outbound direction for R1. I get my point or not? So there is no change in its local BGP table. Still for these prefixes, its local preference is nothing, because it is receiving these prefixes coming from eBGP neighbor. But whenever it will advertise them towards R1, it will advertise them with local preference. And for R5 itself, once again, its best path will become via R6. But only for these last two prefixes only. So I hope that you people have understood that how can you modify and where can you apply and what are the conditions of configuring local preference. So it has also proved that it does not have local significance same as wait. Because wait was having only local significance. Like you changed wait only on one router. I mean on one router, then there was no information about that wait, about that change on any other router. So if they want to ask you, like for an example, if they ask you that, okay, do one thing, use that attribute so that the impact of that will not be on any other device. So you have to use only and only wait. You cannot use local preference, because if you change your local preference, then definitely the impact of that local preference that will be applied on other devices as well in your network. Like this time I made changes on R6, but effects have came on to R1 as well as R5. But remember, if you are giving an update to your eBGP neighbor, then local preference will never be part of your outgoing path attributes. Outgoing updates. I hope that you people have understood all these things. Especially this local preference, that how can you configure and how can you apply and where will you apply, where will you configure it, right? So in this manner, actually we can manipulate BGP path selection with using local preference. Router BGP 65500. Clear IP BGP start out. Once again, its best path is via R5. Local preference is done now. Next attribute is what? Self-advertise. I'm not gonna tell you about this self-advertise. It means that if let's say for an example, I'm advertising one prefix, right, by myself. For an example, see, this is R1, this is R2. Here you are having 12.1.1.0. You advertise. Here you are having your IP address 12.1.1. Here you are having 12.1.2. You advertise this 12th network onto both of them. So R1 will be having in its BGP table that okay, it is self-advertised. Let me show you actually. If you move on New York router, router BGP 81 network 80.1.0 mask is what slash 24, and same network I'll be advertised from BT as well, because BT is also having the same network, right? 35500 80.1.0. Hey, this network is running in between New York and BT. Now you do one thing, move back again on New York router and check its BGP table. Just wait for a moment, it will take some time to receive an update from its eBGP neighbor, because the minimum time interval between two consecutive advertisement for eBGP neighbor is what? 30 seconds. See, what is this? If next hop is 000, it means it is advertised by you.
But locally injected the self-advertised.
Of course, it will not go there. You know why? Because wait is there, right? So you do one thing, if you want to prove it, configure same wait, but local preference will not be compared here. You see, will it compare local preference? Of course no, because from eBGP it's nothing, from itself nothing, so it will not compare local preference. So you do one thing, change its wait. I can change it, like for an example, if I want to see, by default wait is 32768 for directly advertised, I mean for self-advertised, right? So you do one thing, for this neighbor I'll configure its wait as 32768 itself, right? So router BGP 8127 on New York router, say neighbor 80.1.1.1 wait 32 do clear IP BGP star in do show IP BGP. Check it out. Now which one is best? Tell me. Self-advertised. Have you understood it or not?
Yeah.
So remember, self-advertised will be best. So here it has proved that self-advertised is best. So in this way you can prove it. Now again I'm gonna remove it from here. Shall be BGP. Fine. Is it okay now? The meaning by self-advertised, that how BGP selects its best path based on self-advertised. Then after it, let's do one thing, let's move back again on R1, and you see once again its best path for all prefixes is via R5 only, and this time I want to make it via R6, but this time I'll be using attribute AS path. I mean this time I have to do manipulation with using AS path attribute. Have you understood it or not? AS path attribute. So this time you can see that to reach all these prefixes it has to across two ASs, 35500 as well as 8127. Vis Pratap. Your name is Vis Pratap. Vishwanath, sorry. I got my point or not? So to reach all these prefixes via both neighbors, via R5 as well as via R6, it has to across two ASs. So definitely it is not going to select its best path based on AS path attribute. Hello, based on AS path attribute, of course it is not possible for this router to elect its best path. It's not possible because via both neighbors it has to across same number of ASs. Same number of ASs are available inside its AS path list. What to do now? See, we can perform some prependation. We can also modify existing AS path list. We can modify existing AS path list. But remember, you can prepend AS path. You cannot, of course, like append or what we can call it, like prepend is just adding, and to remove append.
Append is adding after it, prepend is adding before it.
Okay. I mean in both cases it is adding, but I mean thing is like inside the AS path list you cannot remove any existing AS. From the AS path list, from the existing AS path list you cannot remove any existing AS, but you can prepend. You can prepend. Are you getting my point or not? So I mean it is something like offset list. Like you can add your metric, but you cannot reduce your metric. So inside AS path list itself, you can add some more ASs, you can prepend some more ASs, but you cannot remove any existing AS number from existing AS path list.
Thank you so much, guys, for watching my video. So we'll be coming back with few more videos of the BGP. Please subscribe my channel. That's @ARC_tutorial. Thank you so much, guys. See you in next video.